All right, we're back in multiplying polynomials here. So the first four problems, what I want you guys to do is a quick refresher. Do them first four. That's from section. Oh, I don't even remember. That's a while ago. That's from a different unit. I want you guys to multiply those first four. Press pause and then hit play and see where you're at. All right, here are your answers right here. The first four. Basically, I did boxes for all of them. I put one binomial up top, one binomial on the side, multiplied through. I'm not going to show the work on that. That's kind of a refresher. We're going to use that same information down below. But before we do any of that stuff, we're going to have some notes we got to take. So let's get to those notes. All right, this is all new information. Really, it's not probably much new, but in regards to this particular section, it is. So first up, remember that a polynomial contains any amount of individual terms. So it could be 1, it could be 2, it could be 3, it could be 57,000. Okay, it doesn't really necessarily matter. There are more specific names for polynomials with 1, 2, and 3 terms. We should already know what those are. We've already talked about those before. But a polynomial with one term is called a monomial, right? That should be something we remember hearing. Polynomial with two terms is called a binomial. And then a polynomial with three terms is called a trinomial. Okay, now, those are the more specific names for those three individual terms. You can still call them polynomials, but we're going to probably want to refer to them as monomial, binomial, trinomial. Anything with 4 or more terms, that's where we're going to use the actual polynomial name. But anything below that, we'll use the actual more specific name for that. Okay, so let's get into some examples here. So first couple examples, this one here you notice is just distributive property. I'm taking the 8 and I'm distributing through. So again, that's 48n minus 16. That's nothing new. You've been doing this since, I don't know, 6th, 7th grade, something like that, a while ago. So this one here is the same kind of general concept. I'm distributing, but if you look at it, I'm distributing a variable with it. Remember when I multiply variables, I actually multiply the coefficients first, so 49, and then I add the exponents of the variable. So 4 plus 2 is 6, and then 7 times negative 4 is negative 28. 4 plus the 1 is 5, so it's n to the 5th, and then plus 7 times 2 is 14. I don't have any n's over here, so it's then just n to the 4th power. So this is your answer for this particular problem here. Number 7. You notice now I have a binomial and a trinomial being multiplied together. Most of you could probably do this already, but for those of you that can't or you need a quick refresher, here we go. I'm going to take the 3n plus 5 and the 5n squared minus 5n minus 7. I'm going to make a box out of it. So I'm going to make kind of big box, I don't know. But we'll go 3 columns. It can be 2 columns, doesn't necessarily matter. And I'll make 2 rows. You can very well flip this box around, doesn't matter. So the 3 terms go on top, 5n squared minus 5n minus 7, and then 3n plus 5 go on the side. And all I do is just multiply through. So 3n times 5n squared is 15n to the 3. 3n times negative 5n is negative 15n squared. Remember, I add the exponents. 1 plus 1 is 2. Negative 7 times the 3n over here is negative 21n. 5n squared times 5 is 25n squared. 5 and negative 5n is negative 25n. And then 5 and negative 7 is negative 35. Now, if I look at this, it's kind of the same general process. I look at my diagonals and I can kind of add them together. So I can kind of combine those two here. And I can kind of combine these two here if you look at them. So let's put them all together now. So 15n to the 3. 25 minus 15 is 10n squared. Negative 25 and then minus 21, that's actually minus here, that's negative 46 n, and then a minus 35 is at the end. So this is actually your answer for number 7 there. So what I want you guys to do is try number 8, pause video, and press play when you're done. Alright, so then again, you notice I flipped my boxes this time. I put the 6p minus 2 up top and the 5p squared minus 5p minus 1 on the side. I did all the multiplication here. Same thing, again, diagonals always work together. For the most part, the majority of the time they always will. There will be some instances where they won't, but you gotta, kind of wait till you get there to kind of look at it. So let's take numbers out there. We got 30p to the third power minus 40p squared, and then negative 10 and negative 6 is negative 16p, and then a plus 2 at the end. So here's your answer for number 8. All right, that was pretty simple. Let's kind of move on here. Okay, if we look at number 9, it's basically the same kind of thing. We have a trinomial and a binomial. Instead of the binomial first, we have the trinomial first. It doesn't matter the order in which these are done. Again, very, very similar. So again, I'm going to put the 8v squared minus 2v plus 8 up top, and then the 5v minus 4 over here. I could very well flip them. It doesn't really matter how they go. Just got to make sure you put all of them on one side. So 40 v to the third, we got negative 10v squared, we got a 40v. It's pretty simple there. Then negative 32v squared here, that's an 8v, two negatives make a positive, and now we have a negative 32, and then I can just pop out. So 40v to the third, remember diagonals are going to be combinable. I don't know if that's a word, but makes sense to me. Minus 42v squared, and then these here are 48v, and then the minus 32 at the end. So go ahead and try number 10, pause the video, and then hit play when you're done. Okay, so I did the box already. Now let's pop numbers out of the box. So the 42a to the 3 pops out. Then I have my diagonals that combine, so that's a 63a squared. And then here, negative 56 and positive 21 becomes a negative 35a, and then a minus 56 there. So there you go for number 10. Now let's go to number 11. If you look at number 11, what do you notice? Now I have two trinomials. It's the same actual process as before. And now instead of taking a binomial and a trinomial, now I'm going to have both trinomials. So v squared plus 6v plus 2 on top, and then I'll put the 5v squared, the 3v, and then the 1 on the side. Again, I make my box. Now it's a 3 by 3 box instead of a 2 by 3 box, and now you have 9 squares versus 6. So just multiply through the same way. 5v to the 4, remember 2 plus 2 is 4, and then this is 30v to the 3, this is 10v squared, then this is going to be 3v to the 3, because 1 plus 2 is 3. Then I have 18v squared, and then a 6v. So then this is going to be a v squared, this is going to be a 6v, this is going to be a 2. Now I'm going to, again, combine diagonals. So 5v to the 4 is going to always be there. The first box never is combined with anything else. Now diagonals. 3 plus 30 is 33. V to the 3. And then 10 plus 18 is 28. Plus the 1 there, that's 29. Remember, there's always a 1 in front of a coefficient, or for a coefficient in front of a variable that has no number there. So that's a square there. Then 6v plus 6v is 12v. Plus 2. Some of you guys might get confused and you might say this is actually 12v squared. You might say this is 1 plus 1. I don't actually add the exponents of variables. When I'm adding, I only do that when I'm multiplying. So when you're adding, as long as the variables are the same degree, means the power of the exponent's the same, all you do is just add the coefficients in front. So there's your answer for number 11 there. Okay, go ahead and do number 12, pause video, and hit play when you're done. Okay, so there's my box here. Now let's take numbers out of the box. So I got the 12v to the 4 is the first box. Again, nothing gets combined with that. 32 minus 15 is 17. V to the 3. And then I have this kind of big diagonal here with the 3 numbers that can be combined. So I got negative 40. I got minus 4 is negative 44 here. And then plus 21 is going to be negative 23 v squared. And then I have 56 plus 5 is 61 v, and then minus 7 over there. So there's your answer for number 12. So those first 12 problems that we just went through are pretty similar. Pretty easy actually too, I believe. And that's something we've already done for the most part already. Now we're going to get into some stuff that we haven't touched before, and hopefully we take good notes when we're doing this. So what we're going to do now is we're going to do something called a Pascal's triangle. What it refers to is this guy named Pascal, that's his last name. He was a French mathematician, and he came up with this triangle that helps us when we talk about binomial expansion. So binomial expansion is what it seems. It's a binomial, so x plus 1. It could be any binomial, doesn't really matter what it is. It could be 2x minus 3, doesn't necessarily matter. And the expansion part is if I take a variable, or if I take the exponent of this whole binomial and I make it an 8 or a 9 or a 2 or a 12, what his triangle tells me is these numbers are the actual coefficients of what it's going to be when I multiply it out. So if you think about this, if you take x plus 1 to the 12th power, the way we currently do that is I would have a box with x and 1, with another x and 1, and then I would get x squared plus 2x plus 1 for the first box, and then guess what? I'm going to do it again, get another thing, I'm going to do it again, I'm going to do it again, I'm going to do it again, and I'm going to do it again. I'm going to do it 12 times, so basically I'm making 11 boxes. And how time consuming is that? It's pretty time consuming, right? So with this triangle, it actually gives us the coefficients, so we don't actually have to use boxes anymore when we talk about just binomial expansion. Okay, binomials. It can't be a trinomial, cannot be anything more than just a binomial. So what these mean is this. This one, okay, think about this. If I take a binomial and I raise it to the 0 power, okay, anything raised to the 0 power is 1. Well, that's where that 1 comes from. Okay, now let's take the same thing, x plus 1 to the first power. That means that the coefficients of both of these are going to be just x plus 1. Okay, so now what's x plus 1 to the 2 power? Remember, it was x squared plus 2x plus 1. Well, where did I get the 2 from? Guess what? There's that 2 right in here in our actual triangle. Okay, that's where that 2 comes from. That's the middle term. And I can keep going through. So these numbers up here correspond to the rows that I'm dealing with. Okay, so this is row 3, this is row 4. That means I have a variable or a binomial raised to the 4th power, and so on. Now, how do we actually get this triangle? Because that's something we need to understand as well. If I look, these sides here are always going to be 1. Okay, they're always going to be 1 all the way down. They can go all the way down this way here. And I got to find the numbers that go in here. Well, how do I do that? Here's how I do it. If you look to this number and look to the 2 numbers above it, 1 plus 2 makes 3. 2 plus 1 makes 3. 3 plus 1 makes 4. 3 plus 3 makes 6. 1 plus 3 is 4. So that's how they're made. 1 plus 1 is 2. The number that you're looking at is made by the 2 numbers above it diagonally from it. Okay, it's kind of like sitting in like a little kind of opening right here, and within that opening, the 2 numbers that are between the opening on either side of it, those are the numbers that are added together to make that number. So let's go further. Let's go to row 5. Let's see what we get. So if I look at this, this is already going to be a 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 5 plus 1, or 4 plus 1 is 5, sorry. And then this is already going to be a 1. So that's row 5. What I want you guys to do is complete row 6 and row 7. Do that now, please. Pause the video and do that. Okay, those are my 2 additional rows for row 6 and row 7. You notice it's 1, 6, 15, 20, 15, 6, 1, and then 1, 7, 21, 35, 35, 21, 7, 1. If you notice, they actually are pretty symmetrical in terms of if you split it right down the middle, one side is going to be the same as the other side. Okay, this one here, if I split it right down the middle, 1, 5, 10, 10, 5, 1. If I split this one right down the middle, row 6, this is kind of my middle term, and then on either side of that, I get the same numbers. Again, I split that one there, and it's that way as well. Now, how does this actually work in comparison to what we need it for? Okay, so now let's get into some examples on how we need the Pascal's triangle. There's a lot of stuff that go with the Pascal's triangle that we're not going to discuss. But there's some addition properties, there's some exponent properties, there's a lot of stuff that go with Pascal's triangle that we don't have time to get into. If you want to know more about that, go ahead and look it up. I know Wikipedia is a pretty good resource for the Pascal's triangle. Again, it's not like, the be-all end-all, but it's a pretty good resource to start with. So this triangle is the one you're going to be working on. You're going to be using this triangle for every one of the problems where it talks about use binomial expansion or use Pascal's triangle or just simplify. Okay, you have to understand what that means. So we're going to do some examples and hopefully it'll make more sense. So because it says expand completely here, that means I want to actually find out what this is using whatever we have in our repertoire, right? So we are very capable of doing u minus 2v, u minus 2v, making a box, find out what that is, and then making another box, and then making another one, and we need 5 boxes total. I don't know if you guys want to spend the time to do that. I mean, you can. I just think you're going to run out of time when these problems get, 6th or 7th power when you get down here. Okay? So we just got to make sure that we're kind of using the best alternative, means like kind of the shortcuts or, fast ways to do it if we have any. So in this particular instance, this is a 6. So you're going to go back to your Pascal's triangle from before, and you're going to go to row 6. And I like to do a couple different things. One of them is, this is kind of the first thing I like to do when I'm doing Pascal's triangle. Once I go to row 6 here, or whatever the row that I need, I'm going to write down the coefficients. So I'll explain what that means. I'll explain how we do that. Coefficients. Okay. So here's what I'm going to do. I'm going to go to row 6, and my coefficients for row 6 are 1, 6, 15, 20. So we got 15, 6, and 1. And you might be like, why am I spacing the numbers out that far? Because I'm going to end up putting other things in here. So these are the coefficients, okay? So then the step 2 is, I'm going to take the first term and go down degrees. Okay, what I mean by that is this. So let's choose a different color here. Let's see if I can. All right. So let's go down. What I mean by down is this. I'm going to take the first term, which is this u here. I'm going to start it with the highest exponent, 6. And then I'm going to go down. U to the 5, u to the 4, u to the 3, u to the 2, u to the 1, and u to the 0. Okay, so I'm going to start at the top and work my way down. That's the first one. So 6, 5, 4, 3, 2, 1, 0. Then I'm going to do the same with the second term. Okay, so second term is 2v. 2v. So that's really the third step, right? So take second term and do the same. Okay, so step 2 is the first term, step 3 is the second term. Let's do the same now. But we have to start low and go high. All right, what I mean by that is this. So 2v. I'm going to take 2v, and this is going to be low. So what's low? 0. This one here is then a 1. This one here is a 2. Then I have a 3. Then I have a 4. Then I have a 5. And I have a 6. So you notice that if I look at my exponents on the u's and the 2v's, 6 plus 0 is 6. 5 plus 1 is 6. 4 plus 2 is 6. 3 plus 3 is 6. 2 plus 4 is 6. 1 plus 5 and 0 plus 6. Okay, they all need to add to the exponent that you actually have at the beginning. If they don't, then you did something wrong and you have to go back and kind of fix it. Okay, so 1, write down the coefficients. Step 2, take the first term and go down degrees. 3 is you're going to take the second term and do the same, but you're going to start low and go high. Okay, so you're going to start low, 0, 1, 2, and then go high that way. And then the fourth and final step is you're going to multiply it out, or multiply through each term. Okay, so here's what I mean. So if I take, it says 1u to the 6, and then 2v to the 0. If you recall, anything to the 0 power is 1. So that means this actually just goes away. And what am I left with? I'm left with just u to the 6th power. Okay? So we've got to remember that. Then this one here is 6 times u to the 5th times 2v to the 1. Well, what's 2v to the 1? That's just 2v. 2 times 6 is 12. U to the 5, v to the 1. This one here, 2 to the 2 power. What's 2 to the 2? Remember, it's 4. 2 to the 2 is 4. 4 times 15 is 60. U to the 4, v to the 2, because I had 2 v's right here. This one here, 2 to the 3rd is 8. 2 times 2 times 2 is 8. Times 20 is 160. U to the 3, v to the 3. You notice my exponents are still adding to 6. 3 plus 3 is 6. 4 plus 2, 5 plus 1, 6 plus 0. 2 to the 4th power is 16. 2 times 2 times 2 times 2 is 16. Times the coefficient of 15, which is 240. U squared v to the 4. Again, 2 plus 4 is 6. 2 to the 5th power. 2 times 2 times 2 times 2 times 2 is 32. Times 6 is 192. U v to the 5. Okay, then this one here. U to the 0 power. Remember, anything to the 0 is 1, so that goes away. 2 to the 6 is 64. 64 times 1 is just 64. V to the 6. I don't have any u's left because I had 0 of them. Okay, it makes a 1. So now, I have to have like pluses and minuses in here, and I have to figure out how they go. So this is something you need to know, write down probably, is because this is a minus, we have alternating signs. What I mean by that is this. The first sign is no matter what, it's always going to be a plus. Okay, always, always, always going to be a plus. So you don't have to write that, but you can if you want to. This is always going to be a plus. So because this one's always going to be a plus, and because I have a minus in here, that means starting with the plus, minus, plus, minus, plus, minus, plus. Okay? So we alternate, starting with the first one, plus, minus, all the way till you get to the end. Now let's rewrite this a little more coherently. Okay, so our answer, we got u to the 6 minus 12 v to the 5, 12 u to the 5, v to the 1, plus 60 u to the 4, v to the 2, minus 160 u to the 3, v to the 3, plus 240 u squared, v to the 4, minus 192 u, v to the 5, plus 64 v to the 6. Now that seems like a lot of work, but think about how much work you would have had to done if you would have had to do boxes. Okay? Think about that. All right? So expand completely just basically says we're going to use Pascal's triangle because we have a binomial here raised to a power. Then I'm going to look at the row, then I'm going to do my steps, and then I have my final answer. So now let's do 14. I'll give you some time a little bit to work on it, but then we'll go through it. So again, pause the video, see what you can come up with, and then hit play. So let's go through 14 here. I gave you a little bit of time to work on it. So let's kind of go through. This here tells me I have to go to row 5. And what are the coefficients to row 5? I have 1, 5, 10. So 1, 5, 10, 10, 5, and 1. Again, remember I'm leaving room there to write things. Then I'm going to take my first term and I'm going to write it, and starting with this number and go down. So 5, this is a 4, 3, 2, 1, and 0. If you think about it, you actually don't need to write the 0 powers because they just turn into 1 anyway. So you don't actually have to write this. Once you get really good at it, you won't have to write that. So then, now I start with my 1. I'm going to start here, and this is 0, and I'm going to work my way up. So 1 to the 0, 1 to the, 1 power, 1 to the 2, 1 to the 3, 1 to the 4, and 1 to the 5. Now let's multiply our numbers together. So 2 to the 5th power is 32. 32 times 1 is just 32, and then y to the 5th, all right, y to the 5th. This one here, 2 to the 4th is 16. 16 times 5, and then times 1 is just 80, y to the 4. 2 to the 3rd here is 8. 8 times the 10 is 80, times that 1 here, okay, is just 80 as well. Well, how am I getting this 1? Well, 1 to the 2 power is just 1. 1 to any power is just 1, okay? So that's just a quick kind of refresher there. And then that's y to the 3rd power. 2 to the 2 is 4, times 10 is 40, times 1 is 40. So that's easy. And then y squared. And this one here is 2 to the 1st is just 2, times 5 is 10. And then that's y to the 1. Or you don't even have to write y to the 1 if you don't want to. And this one here, 2 to the 0 is just 1. That goes away. So 1 times 1 is just 1. Now, in this problem I had a minus. So what did that happen? That means I had alternating signs. Alternating signs. In this particular instance, my sign is positive, so that means every single number is positive. So there's your answer, right there. Find each coefficient described. What does that mean? That means that of all of your numbers, you have a number here, 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 and so on. Okay, all the way through, and we have 7. This is now the 7th row, right? Okay, so what happens is, this term is going to be somewhere in our expansion, and we need to find the number in front of it. That's all we have to do. So let's now do this. This is actually pretty easy here. It's a little bit quicker than what we had to do up top. I don't have to multiply everything. I can just stop right at this one term. So let's get going here. So I'm going to, row 7, this is what that tells me. I'm going to write down the coefficients of row 7. 1, 7, 21, 35, 35 again, 21, 7, and 1. So that's all the coefficients. I'm not going to be dealing with all of them. I only care about the one that has this term there. So how do I find that term? Let's look at it. Remember, the first thing here we got to start with is n to the 7, n to the 6, n to the 5, n to the 4, n to the 3, n to the 2, n to the 1, and this is n to the 0. So this is n to the 3. So that means that I'm going to care about what this term is here. Everything else, I don't care about for the purposes of this particular problem. I can just forget about them. I only care about this one here. Okay, so 35n to the 3. Okay, now this here, we know that it's going to have the m to the 4th here. So I know that this is going to be 2m to the 4th power. Because again, think about it, 3 plus 4 is 7, so they have to add up to what I have here. So now I want to find out what the number is in front. How do I do that? Let's multiply it all through. So I have 35, n to the 3. This 2 to the 4th, remember that's 16. 2 times 2 times 2 times 2. M to the 4. So I'm going to multiply 16 times 35. Okay? 16 times 35 is 560. So 560, n to the 3, m to the 4. But I got to find out if this is positive or negative. So here's how I got to do that. Remember, this is the this is the 5th term, right? Because remember I started with a 7 and then a 6 and then a 5 and then a 4 and then a 3. So this is the 5th term, okay? Because this is a minus, this starts as a plus, minus, plus, minus, plus. So we know that this term here is a positive 560, so that's my answer for number 15. Let's go to 16. I'm going to go to row 5. Let's write down the numbers of row 5, the coefficients. 1, 5, 10, 10, 5, 1. So now y squared is what I care about. So remember, this is y to the 5th, y to the 4, y to the 3, y to the 2, y to the 1, and y to the 0. So I am going to care about this one here. So then this has to add up to a 5. So that's 2 to the 3rd power. 3 plus 2 is 5. So now let's figure out what I get. 2 to the 3 is 8. 8 times 10 is 80. So it's 80y squared. But because this is a minus, it alternates. Plus, minus, plus, minus. So our answer is negative 80 because of the alternating signs. Okay, this particular section is actually easier. So let's get started here. So this is row 6. So let's get started with the coefficients. 1, 6, 15, 20, 15, 6, 1. Because it talks about the third term, I only care about what happens in here. 1, 2, 3. That's the third term. So now let's figure out what I do. So this is 2y. We got to figure out what power it goes to. So this one starts as 2y to the 6 to the 5 to the 4. Because this is a 6 here, this is a 1 to the 2 power. Now let's multiply it out. 2 to the 4th power is 16. 16 times 15, and then times this 1 here. Really, the 1 doesn't matter. But 15 times 16 is 240. Y to the 4th power. And for this one, that's your answer, because that's the term. That's the whole term. Not just a coefficient in this problem. It's talking about the whole term. So they want the variables and all that stuff. So now, 18 here. Last problem of this particular video. So let's all get started here. Let's get amped up for this last one. This 7 tells me what? It tells me that I need to go to row 7. All right, and I'm going to write down the coefficients there. 1, 7, 21, 35, 35, 21, 7, and 1. Alrighty, here we go. So, fifth term. Where's the fifth term? 1, 2, 3, 4, 5. We care about what's that 35 is at right there. So, we need 2a to the what power? Well, this one should be a 7, a 6, a 5, a 4, and this is a 3. That means that that b is the 4th, because it has to add up to that. 3 plus 4 is 7. Okay? So 2 to the 3rd is 8. 8 times 35. Oh man, that's a big one. 280. So that's 280. A to the 3rd, B to the 4. Now, because this is a minus, again, I'll have alternating signs. Plus, minus, plus, minus, plus. So this is a plus. So because it's a plus, it's positive 280. A to the 3, B to the 4. You got some practice problems coming up. It's not too much. Make sure you understand binomial expansion, Pascal's triangle. You will be given some problems on the power assignment that contain maybe 8th or 9th or 10th powers of binomials. All right, so make sure you know how to make a new Pascal's triangle or continue from what you have. Okay, so do the problems, ask questions, take notes, be successful.